Now here's a fun take on one of the problems that will get some of us in trouble if we don't pay very good attention to what's going to happen here. First thing, we want to identify the greatest common factor. Looks like x cubed is my highest power to x that's common to each of the terms. And then with the constant 16, negative 12, and a 4, looks like 4 is my greatest common factor. Let's rewrite that expression. So I'll have a 4x cubed times a 4x squared. You make sure I'm doing my work. Sometimes I make mistakes. Minus a 4x cubed times a 3x plus a 4x cubed times a 1. That's important. That's important. And the reason why that's important, as I pull out a 4x cubed from each of these terms, out of this first term, I'm left with a 4x squared. In the second term, I'm left with a minus 3x. And on this last term, I'm left with, I have to be left with something, I'm left with a 1. I'm not left with nothing. I am left with a 1. And sometimes we forget that 1, and that makes sense. Let's see if, remember, factoring is all about reversing multiplication, what we learned before. So if I multiplied out using the distributive property, the first two terms, that gives me a 16x to the 5th. Multiply the second two, gives me a negative 12x cubed. If there was no term here, I would be done. And then I would have a wrong result. Therefore, I have to have a placeholder there to multiply. 4x cubed times the 1 produces that 4x cubed. So make sure that if one of the terms itself is the greatest common factor, we still need to be, just put a little flag there, put a little marker there that says, I need to be careful with this.